Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. We have been writing a base implementation for tile-based light culling and we managed to finish it in the last video. As you can see here, we are able to render a lot of lights, which is awesome. And although this is working well and we could move on to work on the next topic in our engine, I think it would be wise to spend a bit more time on our lighting system and make it better. So in this new episode we are going to clean up the lighting code, test it more extensively and fix any issues that we encounter, and finally try to optimize the light culling algorithm in order to hopefully get better performance. Today we are going to clean up and test the C++ code for lighting. This way we'll have a clear baseline for measuring the lighting performance before and after optimization of the light culling shader. We start with the structured buffer class, which I added in the last video, but I'm not really happy about how it was implemented. And I don't like it for a couple of reasons. First of all, it's got a confusing name. We were using buffer resources as structured buffers in our shaders before, so this new class would confuse anyone who is not familiar with this engine as to why and when it should be used. It also has this extra UAV functionality to clear the buffer, while this way of clearing buffers is not compatible with structured buffers. That's why we also had to turn off that error in the debug layer of DirectX, as you can see here. Since the purpose of introducing this class was to have something that we can use to clear GPU-only buffers, which can be done using UAVs, I'm going to rename it to UAV clearable buffer. And I'm sorry that I couldn't come up with a better name for it. And we are going to change the way it works a little bit as well. Starting with buffer init info structure, I'll remove create UAV because it's no longer optional to have one for this type of buffer. And because it's not a structured buffer anymore, we can remove anything that's got to do with stride and element count. Now we can pass a buffer size instead of stride and the number of elements. Note that the alignment is now a multiple of 16 bytes. I'm going to add a few assertions in the clear UAV functions to make sure that the internal buffer as well as both unordered access views were created successfully. Next, we update the constructor and release functions in the CPP file. Like I said, creating UAVs is no longer optional, so we can remove this if statement. The view format can be any integer or floating point DXGI format, as long as its size is equal to or less than the alignment. Number of elements is the buffer size divided by the size of an integer. If you chose a different view format, you also need to divide by a size that corresponds to that format. For example, for an RGBA format, you'd have to divide by 16 instead of 4. And finally, we remove the structured byte size, which is now initialized to 0 by default. Now we can use this buffer type for the light index counter. Here I set the size to 1, but remember that the internal buffer size is aligned up to whatever the alignment parameter is. This is set to 16 bytes in case of UAV clearable buffer. So the total buffer size will be 16 bytes. However, we only write to the first 4 bytes in our shader. Since we are not using a structured buffer, we can remove this code for suppressing the error. And we can run the game without errors and warnings. Now let's have a look at the 3D12 light.cpp. Quickly fix a typo here. So here, when we are updating light buffers, we check if the data for each light have been changed in any way by looking at the light's dirty bits. Although I never mind looking at dirty bits, doing so in a loop for every light during every frame is a bit wasteful. Imagine having a few thousand lights and we are spinning the loop just to find out that nothing needed to be updated, and repeat that every frame. So to improve this situation, we can add a flag that we can set when we change something for any of the callable lights. That way we can check if something is dirty, and if that's not the case, we can skip the entire update loop. I'm also going to have a local variable for the number of lights, so we don't call this function over and over. Of course, we should add the new member variable in the lightset class as well. Now, we need to set this variable whenever we set the dirty bits for any of the lights. Therefore, I can write a function and call it instead of setting dirty bits directly. For example, here we can call this function. And because we are doing this assertion in the new function, we don't have to do it here again. So anywhere we set dirty bits, I'm going to replace it with a function call. Here we are clearing the bits, so it remains the same. Okay, now I'll go through the lightset class and clean up the code. Here we shouldn't require that the buffer size is the exact multiple of directional light parameters. It should pass as long as the buffer is at least as big. And I just found an error here in this assertion. We are swapping these owner IDs, and we know that the owner ID at index 1 is invalid. So after the swap, the light owner ID at index 2 should be invalid. That's all for lightset class. Now I'd like to clean up this function, which updates the light buffers. These buffers contain data that's used in the shaders for light culling and lighting calculations. I'm going to rewrite this function so that we have the stuff for directional lights separated from callable lights. Right now they are all mixed together, which is not ideal if we are going to change this function for extra buffers. So basically I'll add two sections here, one for non-callable lights and one for callable lights. And we do each section only if we have those kind of lights. For non-callable lights, we calculate the buffer size that is needed for that many lights. We create a bigger buffer if the needed size is larger than the current buffer size. Then we update the buffer with light data. Note that we do this every frame, since the number of directional lights is assumed to be small. Next section is for the callable lights. So if we have any of those, we are going to see if the buffers need resizing. We do this in the same way as before by comparing sizes. Now we have two buffers that we need to maintain. One for light data and another for culling information. But we only have to check one of them if it needs to be resized, and if so, resize all buffers. We don't need to do this assertion. The reason is that we are going to create our buffers 150% larger than they need to be. This way we can avoid recreating buffers every time a light is added, which could happen frequently. Therefore, if one of the buffers needs to be bigger, so do the others. Next, I'm going to merge these two if statements, which makes the code easier to understand. So if the buffers were resized or we are rendering with a different light set, we need to copy the light data to our buffers. In that case, we clear the dirty bits for the current frame index using this index mask. And we can remove this part. At the end, we also clear the corresponding bit in something's dirty variable and assert that the current light set key is the same as light set key. That's it for this function for now. In resize buffer function, if we are trying to create a buffer with an aligned size that's less than the current buffer size, we just don't do it. Don't do it, man! Never create buffers that are smaller than the current buffer. That's something we don't do, ever. We also don't need to release the buffer, because assigning a new buffer will release the old one. Here we have getter functions, where the referenced lightset parameter can be constant. And that's it pretty much for code cleanup. Now let's have a little fun with our lighting. I'd like to write a bit of code to test some of the code paths that have never been taken yet. Things like adding, removing, enabling and disabling multiple lights, all within the same frame. Let's start with attaching a script to our spotlights to see if the direction will be updated correctly. To do this, we just have to pass a script name when we are making a game entity for a spotlight. And we'll use our good old rotator script to spin the lights around their y-axis. I'll lower the number of lights just to not cripple the frame rate. Cool, I see some rotating stuff happening here. I'm going to turn it off so we can again use lots of lights. Next is a test that will oscillate the light intensity for all lights in the scene. It will do so for both directional lights and callable lights. It's a simple function that calculates a sine wave depending on the light ID. We then use this value for the light intensity. As we all know, however, a sine wave has a value between 1 and -1. So I'm going to square the sine value in order to not have a negative intensity. Then we call this function before rendering each frame. We do need to forward declare it here. Looks like it's working fine. The last test for today is one that disables and re-enables lights, as well as adds and removes them during the same frame. Here in the first block of code, we are going to remove lights at random. So we generate a random number between 10 and 100, and we remove as many lights at random locations within the lights array. We get the entity ID of each light and remove the game entity of that light before removing the light itself. We can copy this code and reuse it for disabling lights. I'll add an extra array where we put the disabled lights so that we can enable or remove them later on. After disabling each light, it's removed from the lights array and put into disabled lights array. Okay, I think I'm going to disable up to 100 lights per frame and remove up to 50 lights per frame. In the next block, we remove up to 50 lights that were disabled. This way, we test if our tightly packed light arrays are working as intended. We add one more block to re-enable up to 100 lights that were disabled. Let's see how this looks with 64,000 lights. Here you can see the lights being removed or disabled, and then some of them come back. However, because we are removing lights, eventually all of them will be gone and we end up with no lights. As you can see, having no lights at all causes no problems and we can keep rendering. Let's add a last block of code which will add a random number of lights to the scene. For this I can copy and paste what we already have here, and instead of having it add lights in a 3D grid, I'll make the positions where the lights are placed random as well. We'll add up to 50 lights at a time, and when I run the application with 0 callable lights, we see that lights are being added, disabled, enabled, and removed. Let's do one more test, although I know I said this was the last test for today, but I guess I lied. So this is really the last one, which will start the application without generating any lights, not even directional lights. And here we have an interesting problem. Because we didn't add any lights, we also don't have any light sets created at all, and yet we are asking for the number of lights in the light set with this key. That's why this assertion is failing. Obviously, when we access the unordered map with a key that it does not contain, a new key value pair will be created and added to the map. The value is an empty light set, and we can call this function to get the number of lights, which is 0. The problem is that if we allow this, and therefore remove this assertion, we can never know if this query with the non-existent key was intentional or happened because of a typo. And this could lead to a confusing bug for a user who doesn't know exactly where to look. In addition, we are doing this assertion in other places as well, which creates an inconsistent API if you disable some of them. I think a better solution is to add 2 new interface functions here that the user needs to call in order to create and remove a light set with a key. Accessing a non-existent light set would then be an error. However, we don't have time to do that today, so I'm going to put it on my to-do list of improvements. It's not complicated to do though, so if you are following along, then you could try and implement it by yourself. Disabling those assertions for now, we can see that there is no problem running the application without lights. And this was it for today. I always enjoy doing code cleanups and a bit of stress testing just to find issues that I haven't thought of before. It also feels fulfilling when the design choices that I've been making are confirmed, or invalidated for that matter. That just means that we found new opportunities to improve the design and learn from it. Hopefully you found this video interesting to watch as well, and as always, thank you for joining me and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!